there is a very important relationship between the speed along the circumference of a circle and the acceleration that's causing that direction change. So we already know that there is an acceleration that causes a change in direction that's always perpendicular to the motion. So for a circle, that's pointed radially inward. So if I were to label this A perpendicular, that perpendicular part, I could also label it as A sub r as the radial part. And there's a historical term for called the centripetal acceleration, so sometimes we label it A sub c. And what's important is that may be a term that we often use, centripetal acceleration, but what's important is that it points radially inward, and it is always perpendicular, being radially inward, from the circle, from the circumference of the circle, or tangent of the circle. Alright, it's perpendicular to the tangent of the circle. So those are the two terms I often like to use because they're more descriptive physically. Now, the derivation to show the relationship is a little bit tricky, relying on some geometry and a small angle approximation, but the result is very important. And so the acceleration, which I'm going to write down as AR, to emphasize that radial nature being perpendicular to the circle circumference, is equal to v sub s squared over the radius of the circle. So the direction changing acceleration is proportional to the square of the speed along the circle divided by the radius of that circle. A bigger circle means a smaller acceleration. That makes sense because a bigger circle means that for some certain time interval you haven't changed direction very much. Okay? But if you're going fast, so bigger v sub s, that means you are getting from one point to another fairly quickly, and that's a big direction change. So this is the acceleration that exists for motion along a circle. Whether or not you're speeding up or slowing down, this is just the direction changing. So this is always there for circular motion. Now, in addition, if you were speeding up or slowing down, you'd have a parallel acceleration. That is just dependent on whatever physically is happening. There's no general relationship, but there is a general relationship. This one is a general relationship between the radial or perpendicular acceleration and the tangential velocity along it. What's really cool about it is it does relate a tangential piece to a radial piece. And so we can actually find out certain things. This gives us another relationship to be able to determine certain parameters if we know this acceleration. And this will become very important when we talk about forces and what forces cause that radial acceleration.